Hello everybody, this is Mr. Yen, and in this video I'm going to be guiding you through lesson 8.2b, where we're going to be talking about perpendicular segments. Here are the key vocabulary and concepts that you are going to be using for this lesson. First is let's review opposite reciprocals. Two numbers are opposite reciprocals if their product is -1. Remember, product is what you get when you multiply two numbers together. Here's an example of opposite reciprocals. We have A over B and -B over A. And add in some color. And so you can see that these two numbers are similar in that one is just the inverse. So it's like flipping the numerator and the denominator, and we've changed the sign. So just when you see opposite reciprocal, think it's flipped and it's changing the sign. And the technical definition is it's the number that you multiply with another number to get to -1. Here's what that looks like. 1/2, what's the opposite reciprocal of that? Well, 1/2 times, and then if I flip the numerator and the denominator and then change the sign, so positive becomes negative, and this would be -2 over 1. This is equal to 1 times -2 is -2. 2 times 1 is 2. So -2 over 2, that is equal to -1. So that's why -2 over 1 is the opposite reciprocal of +1/2. What about -5/3? Well, if we do the rule of flipping the numerator and the denominator, so we would have, starting with -5/3 times, change negative to positive, so change the sign, 3/5, right? Flipping the numerator and the denominator. This is a 3. And if we multiplied those out, we would get -15 as the numerator and 15 as the denominator. -15 over 15, that's equal to -1. That's why 3/5 positive is the opposite reciprocal of -5/3. What about 7? Well, remember, 7 is 7 wholes, so that's the same thing as 7 over 1. The opposite reciprocal of that, well, if you switch the numerator and the denominator and change the sign, we would have -1/7. If we multiply those out, we'd have, this is equal to -7 over 7, which is equal to -1. So that's why -1/7 is the opposite reciprocal of +7. Okay, opposite reciprocals, we're going to use that in just a second. Let's talk about perpendicular lines. So two lines are perpendicular if their intersection forms a right angle. Remember, a right angle is 90 degrees. Right, so just like here, these perpendicular lines, they form a right angle. Now, the key thing to remember here is that the slopes of those perpendicular lines will always be opposite reciprocals. Okay, so another way of thinking about this is if the slopes of the two lines are opposite reciprocals, then we know the lines are perpendicular. They form a right angle. Let's check the slopes of these two lines. We have the slope of AB. So that's here. You can make a slope triangle if that's helpful for you. So we're going 1, 2, 3, 4, 5, 6 is the change in X, Change in y is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the slope is change in y over change in x, so 9 over 6. That we can simplify to divide both numerator and the number by 3 would give us 3 over 2. Next, slope of line segment CD. It's here. And for this one, I'm not going to use a slope triangle, and instead I'm going to use the slope formula so that you can see how to do it that way too. So C, this point is -2, 6. This point is 4, 2. So the slope of CD would be the difference between the two y values. So y2 minus y1. So that's 2 minus 6 over the difference between the two x values, x2 minus x1. So that'd be 4 minus -2. So then 2 minus 6 is -4. 4 minus -2 is +6. The slope is -4/6. I can simplify this by dividing both numbers by 2. So 4 divided by 2 is -2 over 6 divided by 2 is 3. So now my two slopes of the lines are -2/3 and +3/2. Notice that these two numbers are similar, except one is just taking the numerator and the denominator, flipping it, and switching the sign. So these two numbers are opposite reciprocals. Therefore, I can say that AB is perpendicular to CD. This is the perpendicular symbol that you can use. And we always need a because. We know that AB is perpendicular to CD because their slopes are opposite reciprocals. AB is perpendicular to CD because their slopes are opposite reciprocals. Okay, the last thing that I want to show you is kind of a special case, and that's if you have a perfectly horizontal line like AB and a perfectly vertical line like CD right here. We know that this is going to be a right angle. And if we think about slopes and opposite reciprocals, it doesn't quite work the same here because the slope of AB, the slope of any horizontal line is always going to be 0. And it's 0 because you can think as the line gets flatter and flatter and flatter and flatter, the slope gets smaller and smaller and smaller and smaller and smaller until it's perfectly flat. And then that's why it's 0. The slope of CD, this line, well, as a slope gets steeper and steeper and steeper, the number gets higher and higher and higher and higher, until eventually we say if it's perfectly vertical, the slope is undefined. So vertical lines, undefined, horizontal, 0. Therefore, we can still conclude that these two lines are perpendicular, but for slightly different reasons. We can just say AB is perpendicular to CD because they are horizontal and vertical lines. So it's a special case. But normally, you can prove that two lines are perpendicular by proving that their slopes are opposite reciprocals. Okay, that's what you're going to use for today's classwork. And I will say goodbye and good luck.